In the example, we saw that we made the point clause immutable. Now, programming languages such as Scala typically also offer collections, predefined libraries of data structures. For example, for sequences, sets, maps, that kind of stuff. So Scala also supports these kind of collections, and it supports them in two ways. It has mutable collections, which are defined in scala.collections.mutable, and immutable collections, which are defined in scala.collections.immutable, logically. So, for example, suppose I want a sequence that can grow. Then, if I want a mutable version, I can use the array buffer. If I want an immutable sequence that can grow, so meaning I can grow, that I can add stuff to the end and get a new sequence in this case, because otherwise it's not immutable, I can use the vector. So both of them have the following definitions. You can ask for the length, and you can ask to, this is called apply, but this just means the to ask for the element at the ith position. So this is the method that's being called when you use the indexing notation. In the case of the mutable sequence that can grow, I can also update an element. I can say update the element at index by this new element. And this is going to return unit, so it's going to change this array buffer in place. For the vector, you can ask to the updated version, which means change the element at index to element a, which will give me a new vector. Similarly, you can add stuff to the end here, which will change it in place, but here it will give back a new vector. You can also add all the elements of another array buffer to this array buffer, which will update it in place, or you can just concatenate two vectors. So in general, there's all kinds of stuff in the scala.collections.mutable. You have the mutable set, mutable map, mutable queue, and there's a vector and set, map, queue, etc. also on the immutable side. Notice that the array is a purely mutable concept. So what is an array is something that you make that cannot grow, but in which you can update the elements. This doesn't really make any sense. Just use a vector if you want something similar that's immutable. So, a mutable or immutable set, basically they have the same interface. The mutable set has the same interface as the immutable set, but with more methods. So both of them have these kind of methods. Does the set contain something? Is it a subset? Can I add two sets together? So this is the type of immutable changing. You can also do that on the mutable set. There's no reason for it not to allow this. But the mutable set will offer some extra methods, namely the in-place operations. So that's how it works in Scala. In other programming languages, it differs a bit. So typically for sort of imperative programming languages like C++ and Java, the default is to have mutable data structures. In Scala, you can have both. In Haskell, by default, everything is immutable. So also the standard data structures. All right.